Examples of naming. I like the amines, it's pretty straight up. Ethylamine. IUPAC allows that. Primary amines are named by identifying the alkyl group attached to the nitrogen and adding the suffix amine to it. Ethylamine. Isopropyl amine. Cyclohexyl amine. Yes?
The second one could also be called amine.
It could, if the amine was a, so yes, if the amine was going to be purely IUPAC, because it has a higher priority than the alkanes, this would then be a 1-methyl ethylamine, or ethanamine is what they would call it. But you could, because secondary propyl is, there's only one secondary propyl, but we've never used the term secondary propyl because it's the isopropyl. We can have secondary butyl for some reason, but not the secondary propyl. So that's the problem. Oh, I did drink water. Good for me. All right. So, what you would expect to see maybe on an exam is some relevant drug. It makes no sense to put, I mean, yes, it might be easier to just give you ethylamine and isopropylamine and ask you if they are primary, secondary, or tertiary amines, and these are all primary amines. But by the same token, it's more relevant and more interesting if you're a teacher and more relevant if you're a nurse to find it inside a drug. This is a tertiary amine. This is a tertiary amine. Tertiary amine, secondary amine. I don't even have a primary amine up here. But there are just tons of examples of, these are all natural products that are amines. So amines are awesome. Amines, the clarification. So again, this is the clarification of, this is what I would pay attention to. That's a tertiary alcohol, but this is a tertiary amine. That actually is a primary amine, but it looks like a tertiary amine. Understand that? So, it is just by definition. There's no real rationale as to why somebody changed it.
So change it back.
Yes, I believe if you guys donate enough money, you can change it back. So that's something that if you're not really spending enough time on, come test time, you're big at, you've had a lot of experience with the tertiary alcohol, but this is a tertiary amine, and that then is a primary amine because there's only one group attached to the amine. So now it's not, the function group is attached to what type of carbon. That's how it was in alcohols and chlorines and things, but now it's what is attached to the amine. I think that the rationale behind that was the guy who did most of this work, who was clearly popular and wonderful, wanted to put a higher priority on amines than on alcohol groups because amines were so medically important. So he said it should be whatever is attached to it. So this is a primary amine. That's the only thing that I can think that makes sense. And then here is your quaternary. Wow. Looks like somebody jumped on one of these. I would say it was me. I like to climb on the chairs. Wiggins jumped on the chairs. Yes.
So the stability of amines, it depends on kind of what they're reacting. What
Stability of amines.
the quaternary is pretty unstable if it's just on its own.
Well, it depends upon what it's in. You're right. So in other words, it would be happy in a water environment because it's polar. It wouldn't be that happy inside a cell in the nonpolar part. So overall stability, or it'd be not stability, but reactivity of it. Overall reactivity is different based upon what it's connected to. Yes?
Did you just say that quaternary amine is polar?
Yeah, so this would be a plus charge, and so it's like a salt. Salts are more polar than the non-salt. Now, that's also something that may be new. Anytime you have a plus charge on anything with a counter ion, like sodium plus, chlorine minus, they're called a salt. So if you look up medications, and that'd be a good thing to do, you will know that most of your medications are in a salt form. And nowadays, we're smart enough to know that citrate is a metabolite. So there are albumins and carrier proteins that carry them into the system. So that's why we used to just put on the medications a chloride salt, a bromide salt, or a sulfate salt. And some of the older medications still do, but some of the newer ones have, a succinimide, a succinic salt, and a citrate salt, which are things that the body creates. And the idea there is that the body creates it, the body knows how to extract it out of the, GI tract. And so we've started putting citrates and succinates on medications, hoping that they absorb a little bit easier. But it is a quaternary ammonium salt, and so salts are a little bit more potent.
Can you explain why it has a plus charge?
Ah, yes, I can. So this goes back to everything. It goes right back to, because it's an important thing that the book, come on, there we go. It's an important thing that the book ignored. Let's take water for a minute. Well, let's take water and the hydronium, because I've been drawing a plus charge on the hydronium as well. And so, this goes on to that discussion we had yesterday. How many electrons does nitrogen have in its, does it bring to the table? 1, 2, 3, 4, 5, right? How many protons does it have in its nucleus? 5. So it has just enough protons, or just enough electrons that are negative charged to balance the protons that are positive charged. So inside here, it brings 5 to the table. It owns half of all of these that are bound to it. It has an octet. So 5 minus 4 equals a plus 1. Just like the water, what it means is that this had to donate 2 electrons to pick up this extra R group. So now it doesn't have enough electrons around it to balance the internuclear proton charge. Does that make sense? It's the same thing with this. Water brings 1, 2, 3, 4, 5, 6 to the table. And here it has 1, 2, 3, 4, 5, and 6. It's happy, no charge. Here it has 1, 2, 3, 4, 5. So 6 minus 5 is a plus 1. Water did the same thing. And so that tells you, that's how we first got about our Lewis-based property. And nitrogen will take, see, I could get it, I'm running out. If this runs out, and we just might have to quit and go somewhere else. So that's the Friday rule. Oh, shoot, I have more of these in my pocket. It's blue. All right, so in other words, what happens is nitrogen, with its lone pair, comes into some other group, like that has a halogen, like bromine is pulling it away, and it donates its electrons and kicks it out, and that's how it binds to that. So it did donate both of those, and so now it doesn't have enough to balance its charge. It's a salt. It's a salty one. I note these new hats, salty crew. The crusty crew. Salty.
So ammonium with a plus charge is tetrahedral?
Yes?
So where does that plus charge go?
Oh, well, the plus charge sits, so the plus charge, if I draw this, that plus charge is just sitting right, it's just associated inside this, this nuclear area, so to speak. It doesn't sit, we're not talking about a plus charge in an orbital like a cation. It's just associated. So if you were going to really look at it, it's an ionic salt, and I don't know if they talked about ionic salts being the charge being diffused all around it. So the charge isn't really located anywhere in an ionic. But if it was a cation,
So it's not like NH3 where you have that one leg that is.
yeah. So if it's a cation, then the plus charge is in the orbital. Yeah, and so that's a carbocation different. That would be a covalent type of cation than just a salt ion where it's diffused everywhere. So good question. Good question. All right. So one of the biggest take homes is definitely the difference between a tertiary of an alcohol versus a tertiary of an amine. That's something that you've got to wrap your head around, and it drives me nuts. And I'm sure it drives you nuts as well, yes.
Are there going to be other functional groups that are
in terms of primary, secondary, and tertiary.
Yeah, like how,
The-
we're more focused on. what
The amine is the only one that I know follows, that I remember follows this. I have to have three attachments to be tertiary. Everything else seems to follow that pattern.
Attached to the primary.
Yeah, the carbon defines whether it's primary, secondary, or tertiary. And so the amine stands an anomaly to me in that I have no idea who decided that that should be that way. I do know that it's in medicine a lot, and so I'm just assuming that somebody thought that the amine should have more importance, and so it should be the groups attached to it. I just don't know. It drives me nuts. This, if I was taking a fast exam, I would really quickly call that a tertiary amine, and I've done that before in class. And students will say, oh, yes, that's an odd entity that I have to memorize every single time I look at it. Wait, it's up to date. Didn't I get that right today? Whoop me. My brain is younger today than yesterday. But it does drive me absolutely batty. All right. So here you go, primary, secondary, and tertiary amine. Now, I would pull out some I would literally go through and put some alcohol, a tertiary chloride, you know, a tertiary bromide or something, and then set a tertiary amine to the side, and that would be part of my things to study the weekend before a ACS exam. Because there'll be things that you don't have to study that you'll just know. Nomenclature hopefully is one of those things that you're like, yeah, I got nomenclature. Then give me something and I'll be all right. But this, if it was circle, I mean, if you had a question that was circle the tertiary alcohol and then 17 questions later it was circle the tertiary amine under stress, my mind would circle this one here as a tertiary amine. I mean, no, this one here is a tertiary amine. Excuse me. See, now I can't even know what I'm going to do. Ah! Confusing. So I would do that if it's me. I'm a paranoid studier, and again, I circle the things that drive me nuts in fuchsia pink color because it's not my favorite color. Only because that's the first suit that my wife bought for me and made me wear. And it was okay on Breast Awareness Day, not breast cancer awareness day. Ah! I just hide. Moving right along now. How are we on primary, secondary, tertiary? You know, I like to keep you abreast of the things that I do. That does mean a side by side. Is that what is that? Two men walking abreast, walking side by side. Somebody's had to look that up or I'm in trouble. Right. Thank you. Thank you. It's time to go. Ah! Naming things. Now, when you start to name these amines, because it's no longer on a carbon, okay? Organic chemistry is the chemistry of carbon. Okay? So if we're going to use a nitrogen, we have to denote whether or not, and I know these are simple, but we have to denote whether or not the substituent is on the carbon. This would be a 1,2-methyl propane, right? Okay, so we don't put a C in front of it, but if we're going to put a propyl group on here, one of the names would be N dipropyl amine. And the reason that we should put an N out in front of here is so that we know that the propyl is connected to the nitrogen. Yes?
So essentially, we name it very similar to this.
Yeah, so the IUPAC will allow several different names, and a lot of the times for this class at this level, we just call it dipropylamine, okay? Which is okay because we're putting the issue on the amine, but in all reality, we should denote with two nitrogens that both of these are connected to the nitrogen and not connected to a carbon. And it becomes really important when you get to something a little bit more sophisticated. So this would be a triethylamine, right? There's 3 of them, triethylamine. So our groups that are secondary, tertiary, if they're different, what do you think we would do? Don't cheat. We would list them how? Alphabetically. There you go. So I have a propyl, I have an ethyl. Now see here, now we're using it. See? N-ethyl propylamine. So here's what we did. Longest continuing chain that bears a function group of highest priority. This is the longer chain, right? We start at the end near that function group, so this is a propyl group. That means that this ethyl group is on the nitrogen, not on the propyl. So we have to say N-ethyl. The ethyl group is on the N, and the rest of it is the propylamine. Does that make sense? Yes?
So what if there was like another nitrogen on the other side of the propane?
Then we would have to use a rule 5, and that's still a lot beyond this book, but you would name it as a, if it was on the back here, then you'd have a 1, 2, 3, and let's just say that it was an N dimethyl. So you would have a 1, 3 bracket, and then, so you'd have a 1, 3 di bracket, then N dimethyl propylamine, because there's 2 of them. Okay? If you want to know more about that, come to the office, because it's way beyond what we do in this group, and so the rest of you can just ignore that, but you asked that, and so I answer that. It's like a die rule 5. In fact, Ezra's really good for torturing him in recitation. Those are coming into my office and doing that. But that's what you would do. So you would just go to those 5 rules of nomenclature, and when you get to rule 5, you just have to put the die out in front, because you have 2 of whatever's in that bracket. All right. So, are we okay with this? Longest continuing chain, this is a propylamine. If we had a methyl group here, though, we could say that this is a N-dimethyl 2-methyl propylamine, because that's the methyl is on here, right? But again, I don't think that your book cares about that type of complexity. Yes?
So you start out with the N, and then if there's still no oxygen, then you count it.
Yeah, you would count and steal, and if there were substituents on it, you would list them first. So you're going to see this again in ester naming, that whatever the substituent is on the heteroatom, it comes first. So that you can say that, oh, these methyl groups, N, are on the functional group itself. You see, you don't, if you put another group on an alcohol function group, it's no longer the alcohol function group, it becomes an ether. But there is no, this still maintains the amine functional group. So, you had a question?
Yeah, so with the naming with another substituent, so it would be N-dimethyl and then 1-methyl?
Yes.
So it wouldn't be trimethyl
No,
together?
no, you would separate it because this NN shows that it's on the nitrogen.
Okay.
And so it would be an NN-dimethyl 2-methyl propylamine. And that 2-methyl doesn't have an N in front of it, so you know it's on there. Yeah. Now, that said, we just went way beyond what this book will do, I would imagine. So the take-home message is, I have a problem. I'll answer all your questions, no matter how above we're at. But you understand them because you understand the 5 rules of nomenclature. And that's the beautiful thing. You know, you can get to where you can, if you get those 5 rules of nomenclature, you will be better than the people you work with, your doctor, at naming a compound. And it'll drive you nuts that compounds have stupid names like methotrexate or polyunitinib.
What?
Unitinib. There's a lot of these anti-rheumatoid arthritis drugs that end up in anitinib. And I'm just thinking, what Inuit named that? Anitinib. I mean, look at the names of a lot of drugs. They just crack me up. So this is really, I would imagine, what to expect, you know, is just the examples of, I've got an N-ethyl propylamine, I have a triethylamine, if I have two on here, what if one was an ethyl and one was a methyl? Then it would be N-ethyl and methyl, right? Because there's an ethyl group comes first, and I certainly think that that's viable, but they're just showing you simple ones. But I would say, Ezra, let's go through this because that seems like what the IE faculty also would do, is to come in here and say, here I have an ethyl on an amine and a methyl, and so this would be a N-ethyl and methyl, 1, 2, 3, propane amine, or propylamine works too. Propylamine, I think, is what your book does. Propylamine, like here, methylamine, ethylamine, ethyl, propylamine, yes.
E, N, methyl, methyl.
They generally denote them in case you get multiple ones in multiple locations. They separate them out like that. Any other questions? Yes?
So, could,
Yeah, so if I'm hearing you right, that longest chain is the family name, so that's the last thing you put on there. No, because it is, yeah, so you don't have to put the N in front of the propylamine, because this, if it was by itself, would just be the propylamine. It's the parent name. That's a good pickup. What else we got here? We probably ought to, how close are we?
4 minutes.
4 minutes. So here is a simplified version. Name the longest carbon chain bonded to the nitrogen atom by placing the E of the alkane like propane, which has an E, with the word amine, propane amine. Number the carbon chain to show the position of the amine group and other substituents if they're there. In secondary and tertiary amines, the prefix "N" is added to the name so that you can tell where groups are attached to that nitrogen, N-ethyl and propyl. And I've added this for you, and yes, I'm gonna get those uploaded. I need to upload these. So here again, shows you groups that have no priority, and we're up here, right here is the amine just under the alcohol. So if you had a alcohol on it, if you had something like this, let's say you had, and you had an alcohol right here, and let's say you had an amine at the end, this would be a 1, 2, 3, 4, 5 amino, 2 pentanol. Okay? I do not think your book's ever going to do that for you, but Ezra will do a little bit because it just helps you keep your nomenclature on top. And we promise that you will have no problem with nomenclature. You will just spit out very simple. And that's really what we want. We want you to be able to really easily answer all those different things. So examples, yes.
with the chart, you said the thiol was between aldehyde and ketone or ketone and aldehyde?
The thiol should be right here, just above the amine. Yeah. I think it's just below that. And you can look up on one of your earlier ones, on the alcohol chapter, I'll have where that thiol is in relationship to the amine. You betcha.